Jose, I recorded this screencast to present to you a potential product idea that perhaps you may be interested in. Considering some results in kidneys that I will show you, I believe that similarly to what occurs in other diseases, the ectopic mineralization in ALPL knockout mice may result from simultaneous different alterations. I investigated untreated knockout and Y-type mice at E17.5, P1, P7, P10, and P18 days. I noticed that the embryos, P1, P7, and P10 mice, they presented diffuse calcification that weren't noticed in the Y-type animals. So, as we can see here in the embryos, the knockouts, they have this diffuse pigmentation, and we don't see here in the Y-type. The same pattern is present here for P1, and the Y-type P1 is absent. And again, P7 knockout, we have these pigmentations, and again the Y-type we don't have. And I just want to remind that I stained everyone together. So when I found the embryos and P1 results, I thought interesting because in my mind the P1 and embryos, they wouldn't have the calcification because they were receiving some level of ALP from the mothers, but it didn't happen. And again, for the P7, P10, I had the same idea. I imagined that from the milk they were receiving the ALP that would be enough to prevent it, although the mother is heterozygote and has a lower level of the ALP. So here we observed in P10 that they have the same pattern as before, and also if we look here in the wild type, we will notice that the P10 presented a delay in the kidney maturation when compared to this animal. So here in the Y type, we can see the medullary cords. They are very well oriented and they have clear distinction between cortical and medullary area. But looking back to the knockout, we don't see these medullary cords yet, and they are not oriented. Okay, so then I consider that the blood and the milk of the mother, but then observing the knockout P18, we saw the persistence of the calcification and they were not receiving blood or milk from the mother. So I believe that different mechanisms are involved, and we again see that the persistence of calcification and somewhat, in some extent, some intensification. And the results from KIMAP, those knockout P53 KIMAP 16 mice, they didn't present nephrocalcinosis or other ectopic mineralization in aorta, stomach, and lung, except to those two mice in the lungs. So it seems that the KIMAP corrected that. But when we look at the treatment for 119 days, we see that they have extensive calcification areas in kidneys. Also, we can see here in lungs and here in the stomachs. So for this reason, I think that many mechanisms may be involved in this mice model, that certainly the age is related. It's a mechanism age related. And so I would suggest the following investigation. I think as a first step, we should compare knockout and Y-type kidney primary cells in normal culture conditions. Then we can assess whether they have different levels or expressions of certain molecules that are related to mineralization. So some related, like they can intensify or they can prevent mineralization in soft tissues. So like these molecules. I don't know, maybe we could explore different age, or just start with P18. I think could be a good start. Also, I think we need to verify if we explore the medullary cells first, or we explore cortical too. There are techniques already checked to collect separately those cells, and I think maybe we should start with the medullary, since we saw the delay in the medullary formation, and also 98% of the nephrocalcinosis is present in medullary areas. So I think we should start by that. So once we have this idea regarding the difference of if there are, but I believe yes, differences in the knockout and wild type cells, then we could induce, in cell culture, we could induce the nephrocalcinosis and check which had altered, which had overexpression or not, and of those molecules or other that we could think by them. Probably it will be possible to run all the projects together, all the ideas, like run the normal condition nephrostasis, but maybe we should start with the normal, and from that results we do the second step. Also, besides alteration in proteins and other molecules, maybe we could explore other cellular alterations. Okay, and as a third step, that there's a possibility to run together with the first and second. I could check, like I did for the kidneys, I could evaluate the knockout mice at different time points for other organs, like lungs, the stomach, aortas, to see if they have some alterations. And finally, depending on what kind of results we obtain from step 1, 2, and 3, we could try to modulate this ectopic mineralization in this kind of mice model, maybe through conditional expression or maybe other alterations. I know that you're already working on some conditional expression other models, but maybe we could think in something in this ALPL mice model. I believe that these steps, they will give us a very good understanding of the ectopic mineralization in this mice model. And considering that hypophosphatasia patients, they are receiving treatment, and they probably, I hope so, they will live much longer. Maybe this extension in their lifespan may be accompanied of more and more cases of ectopic mineralization. So I think this study will be important because it will provide tools to help such patients or to develop some treatment for them. And also maybe our results will be useful for different type of disease that present the same ectopic mineralization, and maybe would be helpful for other kind of patients. And finally, I believe that this idea can be founded by some agencies like this one and other foundations. We have other, I couldn't check all, of course, I know you already do this, but just to show that I am aware that we could, maybe I could draw better the project and then give to you to apply for grant, or maybe, and I can apply for fellowships too. And I recorded this screencast because I really liked the 2 years spent in your lab, and I would like to stay longer. I like the area, the research area, and although I understand the problem of funding, I know that's difficult to keep a postdoc. I know all the money that is involved to produce a complete research. And but if you don't think this idea is good, or these ideas would not be fundable, and if you have some idea, I'm willing to try. I have the 2 offers in Brazil, the Manaus, and a new offer in Bauru. It's a private dentistry institution. But if I could choose among the 3 options, I would choose your lab. And I think it will give me more professional satisfaction. So we can talk about it in person, of course, and if you like the idea or if you have some suggestions, we can discuss. I can also present this to Manisha and Sunoko, and maybe they can give some highlights on what to do. Okay, thank you very much.